Good morning, everyone, and thank you very much for giving me the opportunity to present. This is a continuation of supply chain again, because you can't avoid that, especially when you're talking about disaster response or mutual assistance, especially in disaster and emergency management. So I'm also excited with the new product, and I have a feeling, I had the same feeling last year when the new version of AnyLogic was coming and saving time in terms of adding more especially GIS-based activities and functions in that. I was saying to myself, I should have waited for this new product because I spent much time developing some works that now can be done in a few seconds, basically. Same, I think, what's going to happen with AnyLogistics, and it's going to help a lot in terms of, or for people who want to do this kind of simulations. Very briefly, this project we are doing. We are doing actually a number of projects. We call them startup projects as part of a facility and center we are developing at York University. It's called Advanced Disaster Emergency Response, Rapid Response Simulation Center. These are some of those initial projects we have ongoing. Now we have, on this particular project, we have, of course, York University beside us, and this project is funded partially through our National Science and Engineering Research Council under what we call it the ADERSIM program. This is Answer Create program. And we had opportunities to benefit also some sort of funding from Toronto Hydro, which is the largest hydro company in Canada, based in Ontario, and also a group of experts from NAMEC, this is North Atlantic Mutual Assistance Group, and also some anonymous responders to our surveys and people who participated in our discussion. So the question here that I'm addressing is basically that most utility companies, by the way, this project is focusing on how utility companies try to help each other during disaster events. Now, what their goal is, when disaster happens, their customers are impacted by power outage. What they want to do is to reduce this time, outage time, and as fast as possible. So for that, as you can see, for example, in 2012, just because of weather-related events, not talking about other incidents, we had this problem of cost, which ranges from something between 25 to 70, the different estimates says $1 billion for those costs. And this cost for different type of events varies from the beginning to the end of the process. And depending on the nature and size of the disaster, you will see it takes longer for hydro companies to bring back the customers to the power. And so for them to reduce this size, it not only helps them to make their own business, but also helps the whole economy to survive in these cases. So it's kind of social, private type of optimization, if you like. And now, what companies, hydro companies, for the past few years have come to solve this issue of being able to reduce this outage time and period or number of customers out of power is to create some sort of alignments or groups, they call it, to help each other, mostly through human resources and equipment, so that they have the capacity or they'll build up the capacity to help each other in those cases. They have different arrangements, but these maps basically show you some of those arrangements. For example, you have what they call it NAMEC, that is for North Atlantic Mutual Aid Group, that includes a number of U.S. states in the Atlantic part, plus some of the utility companies in Canada. It's expanding to Canada, and they become a member of these. And so forth with other utility companies. That's how they try to help each other. Now, for example, when we had in December 2013 this ice storm that happened in Toronto or Greater Toronto area. Just in Toronto, we had a large number of customers, probably around 300,000 customers out of power in the middle of winter, of course, which is quite cold at that time, and it was in Christmas time, holidays. So the hydro companies had difficulty bringing in or bringing back the power to all customers, not having access to mutual aid or other companies' basically resources. So after that event, actually they tried to join this group and be able to access those resources. Even in that particular incident, for example, hydro company, Toronto Hydro, had its own resources, which in terms of number of personnel, it counted for 1,250 people, but they had to bring in people, around 400 other crew members who are able to do these kind of things to help them. And they came from US, from other provinces in Canada to help them. But same also, for them, this was what happened in terms of the speed of recovery or restoration of power to people, which was possible or became possible with bringing in other resources from other places that shortened this time period. And now, still it is probably too long, especially from the beginning. So they are looking for ways that they can bring in resources on time, not after 2-3 days delays, and also to bring them and distribute them into the areas that are impacted by disasters so that they can reduce this time frame and also be able to better coordinate with each other. And this could happen, this could be a different graph had they didn't have access to, let's say, these resources. Of course, if they had access to more resources, probably they could even shorten this period. This was also true in case of some of these recent disasters in US, and part of you might have been in those cases. And these graphs basically shows when these kind of mutual assistance were available to them. The problem here is that in some cases, these hydro companies that are trying to help each other, they also being impacted with the same disaster, or maybe another disaster of the same or different nature. So they are not necessarily always available to help each other. So for hydro companies, this is like a dilemma, whether they would be able to get access to these resources or not when disaster happens. So they have to make kind of decision, that is very complicated and with lots of uncertainties. In this case, I don't want to go to details, but this is what happened, and a number of in some of these disasters, you are talking about the millions of customers without power in one time. Now, what we're trying to do is to help or develop a tool or a methodology that helps hydro companies or other companies also doing the same mutual assistance during disasters to make a better decision whether the question is whether they can provide mutual assistance from responding, what we call it, company's perspective, and also from what they call it, requesting companies, if they can count on their mutual aid groups or not when disaster happens. So this is complicated problems, and also has different dimensions depending on from which angle you are looking at it. We are trying to help both directions, and hopefully in the future we expand that. But this startup projects helps us and them understand whether these kind of approaches, simulations are feasible, helping or not. So this process or this project is, in terms of methodology, we have what we call it our decision part, which is basically, I'm sure most of you know about this process. We have combined what we call it analytical hierarchy process and also a Delphi method to identify the criteria that are key to decision making whether and if hydro companies are going to provide this kind of mutual assistance or not, and also using the same methodology to capture the weights for different factors that are contributing to this decision. And then fit this into a simulation that helps run this simulation and for different scenarios again to see from requesting companies' perspective if they can count on this. And once they identified which are the potential providers, supply or resource providers, how long it would take for them to reach the impacted areas and the rest. I mean, that's the target. And this could continue and improve the process. We did this. We identified this, as I said, through Delphi method and analytical hierarchy by bringing in a number of experts who have been in this business or in these situations for the past 10, 20 years. They have been key decision makers within their organizations. So we asked them what factors are contributing to these decisions first, and then group those factors using analytical AHP model, and then developed what they call it an online survey through interview, a kind of mix of interview and also this survey. We went basically called them, provided them with online access to this survey, and as we discuss and talk to them, they fill in the survey. So that is not just them doing the survey on their own. We went to see what are the reactions, what are the comments, and so on. So we came up with main groups of decision criteria, if you call it. Some of those are related to mutual aid responding situation. Some of them are related to mutual aid requesting companies' situation, and some are to the disaster situations. And then you go to the lower levels of criteria. For example, I'm not going to discuss all, but for example, in terms of mutual aid responding criteria, you had, for example, emergency conditions at home. If a utility company experiencing disasters themselves, they are not likely to provide service to others. Or another factor was availability of resources. Sometimes disasters happens, the responding utility company is willing to provide, but they don't have the resources that can help, either because they're already engaged in other projects or because they are simply not available to be deployed. And we have also the time it takes for mobilization of these resources, and also work backlog. Some utility companies have contracts already, so if they go to assist others, while they come back and they cannot meet their own contracts, then they would be in problem. They have to, of course, compensate for that. By the way, I did forget to mention that all these assistance is based on the requesting company's cost. So if a company goes to provide assistance to others, they invoice the requesting company from the beginning to the end. So the cost is not an issue for the responding company. It's more of an issue for the receiver or requesting company from that angle. But we did not include costs in this because we don't want people to assist. I mean, this is more of assistance, real assistance in case of emergencies. So you can include the cost in other way, but not as a preventive measure for your assistance, basically. Now, once we finish this process, adding the criteria to the presenting them to experts, came up with, and doing the process through an analytical hierarchy process, we came up with the weights for these 13 criteria we added and sub-criteria we had, and different of them had different weights. Of course, for example, you see the more weight we had for size of disaster and emergency event. Usually, if a disaster is large, like Sandy, like ice storm that we had, and the different you can imagine, or Hurricane Katrina, just because it is exposed in the media and because they feel it is a real big disaster, so the move toward providing assistance is larger than normal ordinary disaster situation. Or another factor was emergency conditions at home, as I explained it before. It impacts whether they want to provide this assistance or not. Now, once we found out the weights for all those decision criteria, we came to ask questions about the realities and facts about disaster mutual assistance in the past based on the experience of these people. For example, these are helping to build and add the values for the simulation part of our model. For example, we needed to know average or approximate mutual number of mutual aid FTs or full-time equivalent people. In a typical, for example, we asked them for a typical disaster assistant, how many resources or how many personnel you provide usually. So we had different numbers. You had the maximum of 250, and you have low number of, for example, 12. And we also asked them, for example, the distance that they traveled to provide this mutual assistance. So again, it ranged between the maximum distance and minimum distance. We had a range of them. Some companies travel like 3,000 kilometers to provide assistance. Some they don't, or so this was something we also captured. And we asked them, for example, average number of personnel in crew, because different companies use different crews, and different crews have different personnel. Some of them have 2, some of them have 5, some of them are 6. But for our simulation, we needed to know what are the ranges in this regard. And also average operational period, how long usually they go to provide this assistance. It again ranged from something as low as 4 to something at 14. By the way, this is a very important thing here, the time, the operational time. Many companies, they say, for example, if we have to travel, for example, 2,000 kilometers just to provide service for 1 day, it doesn't work for us to go all the way to that. They usually say, as kind of very basic criteria for them, they say we have to be there at least the same amount of time we spend in travel to be helpful. So you can see these ranges. Some, if they think that this is going to be less than that, they usually don't travel that long. And we also ask a question like time to decide to mobilize and cross the borders, and so because there is a mutual assistance between Canadian and US companies here, we need to consider the cross-border issues. Usually they have to stay in borders, and often it goes something from 2 hours to sometimes 10 hours, depending on who they are sending and what are the particular issues that these people don't usually consider in when crossing the borders. And so you had a range of, as you can see here, of different time frames for mobilization, decision to mobilize these resources, and so on. We use these variables, or these values as input to our simulation. So we started doing this simulation. Basically, the goal was to simulate various mutual aid or mutual assistance scenarios, and also looking at these inputs as our input to the simulation. And the output would be, for them, would be useful to know what are the potential number of crews and FTEs arriving in the particular scenario, based on this decision process that exists between hydro companies when they want to make decisions whether to send or not mutual assistance. So very simple. It's not, I mean, this is an ongoing project. We can say this is probably the first presentation of that. We had a prior presentation to some of our experts to see what they feel, but they asked us basically to continue, and they found it interesting to work and develop it further, let's say. What you see, of course, has the GIS base that includes number of agents, including the border crossing points, plus the utility companies, and also crews. So you choose what is the requesting company from the list of existing companies, and if you want to run it just for one requesting company, one responding company. You can choose also from the responding company, but if not, this model runs for all of them. You set all the parameters that I explained based on the expert opinion that we found are key to decision making regarding this issue. And then weights are already extracted from the AHP process, which is a collective expert opinion on those. But we also allow people to go and change this if they feel they have to adjust some of these based on their particular conditions. But we don't advise because this is a collective thing. And then this is a snapshot, very simple snapshot of utility companies' state chart, where you have the process by which the responding companies receive the call from the requesting company. They start making decision whether they should provide or not. That is where this decision criteria come into place. And then if this process is providing the score of certain amount, which has to be, in this particular model, has to be above 9 to, this ranges from 0 to 10, to 15. So we are saying that if it is, for example, above 9, this mutual assistance makes, it has some rationale behind. And then it goes to the path to mobilization of the teams. And as they start mobilizing the teams, you will see the results. These are some of the results for each. You can get this for each company. You have the weights, which are fixed unless they change it. But the factor values would change depending on the specifications of the utility companies. And then once you run the model, it starts uploading the crews for those responding or those who have made the decision to respond, and it brings in then the number of hours it would take, of course, using the network in terms of distance, but also amount of time that they spend on mobilizations and passing the borders as well. Now, this is for a typical scenario. Using these values for our decision, for example, in this case, we have come out of those number of utility companies, those in, I think, purple, purple, they are those who are showing interest or they feel it is something that they can respond to. And then depending on the timing that they have in processing those kind of things, based on the average that we provided. And this can be also, we can use probability distributions here if we don't have the actual data, but if you have the actual data, you can insert this here. And then they start moving toward the impacted utility company, and at any given point, you can find number of arriving crews, and from then you can go into tactical decision-making process to distribute them into impacted areas, or as they come, you can also divide them, sending them basically. If you have already identified, usually this is the case, where they have to go, you can, as they are coming toward you, you can tell them where to go. And this provides utility companies also a tool to make better planning in advance, not just when disaster happens, although this is the intention. As soon as something happens, they can run the simulation and do some initial planning, but they can also use this for simulation exercises, pre-planning of potential scenarios that they will face. We have some more works to do with this simulation. In particular, for example, we want to test this with some of the real cases in the future. We have already lined up some of the utility companies to help on that, and we're also hoping to add some sort of multi-responding, multi-requesting scenarios to this. A lot, as you can expect, to be added to this, but hoping that this would help, better management of disasters, especially keeping you warm and having you your home with power when disaster happens. And that's the idea, to limit. I personally experienced this situation during the 2013 ice storm. I was impacted by this for 5 nights. We didn't have power. We didn't have much alternative. And At the end, after 5 days of not having power, we decided to move south. We came for a conference to Chicago and spent there. And by the way, by the time we went back, we had power back. But this is basically the idea, and I hope we do something that is going to be useful. And by the way, if you have any comments, suggestions, this is in the earliest stage. We would welcome all your suggestions, comments, and thank you very much for attention.